My name is Natalie Kerr, and this is my MSIR spectroscopy video, and in it I will be analyzing succinimide. So to start off, we're going to take a look at the MS graph, and the first thing we want to do is locate the molecular ion and the base peak, which in this graph are the same thing, and that's at the 99 point there. So this small peak beneath it is much less than a ratio of 3 to 1, so we know that there are no chlorines present. And there are also no double peaks, so we know there are no bromines either. And now then we just ignore everything to the left of our base peak. So now would be a good time to look at our IR graph to see if we can determine if we are dealing with anything besides carbon or hydrogen, since the MS doesn't give us much more than the molecular mass of the compound. So here is our IR graph. In our IR we have 5 zones. Zone 1 is from 3,700 to 3,200. Zone 2 is from 3,200 to 2,700. Zone 3 is from 3,200 to 2,000. Zone 4 is from 1,850 to 1,650. And then Zone 5 is from 1,680 to 1,450. And then everything to the right of that is the fingerprint region, which is found below 1,450, and we don't need to worry about that because it is far too specific to each compound to be helpful. So we've got a couple peaks here that we're going to pay attention to, and then a couple peaks here that we're going to pay attention to. And we're going to use this graph from compound chemistry to figure out the specifics of what we can find in each region. So those 2 peaks that we saw at the low end of zone 1, or that one main peak, right, this one peak at the end of zone 1 that's kind of on the edge of zone 2, it looks like that is probably an amine. It's got that nitrogen to hydrogen bond right there, and then it could also be potentially an alkyne, or it could even be an alkene or aromatic or something like that right on the edge there. But because we know that our compound has nitrogen in it, it's probably going to have to do with this right here. And then we also want to look at these 2 peaks, and those are going to be indicative of an oxygen double bond right over here in that region. And with this knowledge that there's both nitrogen and oxygen present in our molecule, we can take it back to our MS graph here. And we're going to use that base peak number and the molecular masses of the different components to figure out exactly what we're dealing with. So to do those calculations, we know that we have nitrogen, oxygen, carbon, and hydrogen. So we'll start with nitrogen, and we're going to subtract the molecular mass of 1 nitrogen from the molecular mass of our component. So 99 minus 14 is 85. And then we can do oxygen, so we're going to take a guess and say that there's 2 molecules of oxygen, which gives us 32. And so 86, whoops, sorry, that should be 85, minus 32 is equal to 53. And then 53 divided by 12 is equal to 4, which is how we find our carbon there. So if we work backwards here and we count up the molecular mass of these 3 components so far, we get 94. And if we subtract that 94 from the original 99, we're left with 5, and since hydrogen, the molecular mass is 1, we know that there are 5 hydrogens. So the last thing that we have left to do is to find the degrees of unsaturation, which is equal to 2 times the number of carbon plus 2 plus nitrogen minus any halogens minus any hydrogen divided by 2. So for our compound, it's going to be 2 times 4 plus 2 plus 1 minus 0 minus 5 divided by 2, which equals 3. So this means that we have 3 degrees of unsaturation, which means that there's some sort of combination of rings or double bonds in there, and there's going to be 3 of them. And we know that 2 of those degrees of unsaturation probably belong to the ketones that are formed from those oxygens that we saw in the IR graph, which means that we also have another double bond, or our compound is a ring to make that final 3. And in order to have 5 hydrogens in our compound, we can assume that is a ring. So if we draw that out, it looks like this, and we can see that we have 2 oxygens, 1 nitrogen, 1, 2, 3, 4, 5 hydrogens, 1 ring, and 2 double bonds, giving us 3 degrees of unsaturation.